Today we're looking at lesson 3.6 for geometry. This is on perpendiculars and distance, finding the distance between two parallel lines. So the first example relates to these two key concepts, or actually just the first key concept particularly, where you're trying to find the distance between a point and a line. And usually the shortest distance between a point and a line is going to be the distance that is making a segment perpendicular to the line from the point. So if you look at the segment coming from point C to line AB, that's going to make a perpendicular line. So if we were to construct a segment here where you would have the shortest distance to a point, and you would come up with your own point, let's say S, you would make the segment perpendicular to S. So it would look like, perpendicular to PR, and that would make the shortest segment. So we are going to actually look at this a little bit closer on Monday, where we're going to actually construct our own segments the more exact way than this, but the idea is that the segment going to the line needs to be perpendicular to that line, and that will give you the shortest distance. The next problem we're going to do is we're going to find or construct a line that is perpendicular to line L, and it gives us the points for line L. So we're going to first need to figure out the equation for line L, and then we're going to find the distance from the point to the line. So we did a little bit of this already in class, where we were trying to find the equation of a line when given 2 points. So if the points are 1, 2, and 5, 4, we're going to find the equation for that. Sorry if you can hear that, that's my clock going off at my house. So we're going to use the 2 points first to find the slope, and we're going to write our equation in slope-intercept form. So we are going to subtract the y's over the x's to get 2 over 4, or 1/2, and that's going to be our slope. And then we need to find our b using one of the points. So we're going to plug in, let's just use the smaller numbers, 2 for y and 1 for x. So we get 2 equals 1/2 plus b. And again, we're going to get b by itself, so we're going to subtract 1/2. So we get 1.5. So if we put it all together, we get b is 1 1/2. So we have 1/2 x plus 1 1/2. So when you're trying to find a line that is perpendicular to another line, and then finding the distance of that line, we start by writing an equation of the line. So the equation is y equals 1/2 x plus 1 1/2. So now ultimately we want to construct a line that's perpendicular to the line we just saw. So if we're thinking of a perpendicular line, that means we need to make the slope perpendicular, and then it also gives us a point that's going to be on that perpendicular line, 1, 7. So we're going to use that point as well. So if we think about a line that's perpendicular to 1/2 as the slope, that's going to be the reciprocal and the opposite sign. So that would end up being -2. And then we need to find a new b using the point that they gave us. So I'm going to plug in 7 for y and 1 for x. So that gives us 9 for b. So our perpendicular line then is now going to be -2x plus 9. So that would be our second step. So the first step was to make a line of the line that we're trying to make a perpendicular line to, and we have that equation. And then the second step was to make the perpendicular line using the point they gave us. So with these two equations, we're now going to solve. This brings back algebra here, where we're solving the system of equations, and that's where we're going to find our point of intersection. And we're going to use that point to then find our distance. So we need 2 points, obviously, to find a distance. So we have 1 point right here, 1, 7, but we need another point. So we're going to use the 2 equations, solve them, and then find another point. And that's going to be our 2 points that we're going to use for the distance. So here's our 2 equations. If we're going to solve, the best way to solve this would probably be to use elimination, since we have, if you remember back to algebra where we did substitution or elimination to solve systems. Elimination would mean that we're going to eliminate one of the variables. Since we have the y's being the same, to eliminate them, we're going to end up subtracting. So then we subtract everything from each other. So we get the y's cancel each other out. Then we have 1/2 minus -2, which ends up being plus 2 or positive 2.5x. And then 1.5 minus 9, which gives us negative 7.5. And we're going to solve for x. So we add the 7.5. I would make the 2.5 into an improper fraction here, so 5/2, because then we're going to have to multiply by the reciprocal to get x by itself. So then I would actually make the 7.5 also an improper fraction, so 15/2. So we have 5/2 times 15/2 equals x, so that's going to be 75/2, which gives us 37.5. Okay, so I actually caught myself because that 37.5 did not look like it was the correct answer. So I told myself that I'm multiplying by 2/5 back here, but I multiplied by 5/2. So let me erase that. That's 2/5 is what we're supposed to be multiplying by. 2/5. So that makes a little bit more sense here. So a smaller number. So we have 2/5 times 15/2, which gives us 30/10, or 3. So that's our x coordinate for our second point. Now we need to plug that into either equation to find our y coordinate. I'm actually going to plug it into the second equation because we don't have fractions. So if we do that, we have y equals -2 times 3 plus 9, or -6 plus 9. And this doesn't always happen, but it looks like y is also going to be 3. So we're going to then take the 2 points, 1, 7 and 3, 3, and find our distance. Oops, I ran out of room here, so I'm actually going to erase this slide a little bit. And use our 2 points that we found to find our distance. So a distance formula is what we need. That's going to be subtract our y's, square them, subtract our x's, square them. So we have 1 minus 3 squared plus 7 minus 3 squared. That gives us -2 squared, or 4, plus 4 squared, or 16. And then our final answer, the square root of 20. We can actually leave it as the square root of 20, but that's going to be our distance between the perpendicular line, the point on the perpendicular line, and our other line. So that's the first example. The second example will relate to these key concepts, where you have the distance between parallel lines. So we're going to find the distance here between two parallel lines. Again, that's going to be a perpendicular distance. So it's kind of similar to what we did for this last process, but we're going to do two problems related to that. So finding the distance between the parallel lines, R and S, and they gave us the equations this time. So the first thing we're going to do, since our lines are parallel here, is we're going to come up with one line that is perpendicular to one of our lines. So we're going to use one of the same y-intercepts of one of the lines, but then we're going to change the slope. So let's say we use the y-intercept 0, -5 from this line. If we're coming up with a perpendicular line to that, that means our slope is now going to be positive 1/3. So if we came up with an equation that's perpendicular to this line, using its y-intercept, because it has to intersect the two parallel lines, this would be our new equation. So from there, we're going to take this equation, the perpendicular one, and the equation that we made it perpendicular to, the other equation, so this one, that we didn't take its y-intercept from, and we're going to solve that system. So we're going to do y equals 1/3 x minus 5 and y equals -3x plus 6. Oops. And we're solving this. Again, we can use elimination with subtraction. We get 0 equals 3 1/3 x minus 11. Solving for x. I'm going to change this to an improper fraction to solve. So I get 33/10 equals x, or 3 3/10. I'll just leave it as 33/10 for now. Now we need to find our other point. Our other coordinate here, so we're going to plug in x. If we already have a fraction, might as well plug it into the one with the fractions. So if we plug that in, we get y equals 1/3 times 33/10 minus 5. That gives us 33/30 minus 5/1. We need a common denominator, so I'm going to multiply both by 30. So 33/30 minus 150/30, which gives us -117/30 for y. So my point is 33/10 and -117/30. Oops. And now I need to go back to using my other point, which comes from the perpendicular line that I started with, so the y-intercept of that, which is 0, -5. And these are the 2 points now that I'm going to find the distance from. So if I use that in the distance formula, I have my x's 33/10 minus 0 squared plus my y's -117/30 minus -5 squared. So that becomes 33/10 squared plus 33/30 squared. I'm actually going to change them both to decimals because these fractions are going to get real tricky. So 33 over 10 is 3.3. If I square that, 3.3 times 3.3 is 10.89. So 10.89 plus, again, making 33 over 30 into a decimal. That's 1.1. If I square that, that's going to be 1.21. So 1.21. And then I'm going to take the square root of that. So 10.89 plus 1.21 gives me 12.1. And again, I can just leave it in terms of square roots, but that's the distance between the two parallel lines. Now we're going to do one more where they do not give us our equations in slope-intercept form. So I'm going to put them into slope-intercept form first before I start. So if we have x plus 3y equals 6, and I'm putting that into slope-intercept form, I'm going to get y by itself. So subtract the x and divide everything by 3. I get negative 1/3 x plus 2, and then x plus 3y equals negative 14. Again, subtract the x. And divide everything by 3. So my other equation is negative 1/3 x plus 14 over 3. So if we remember correctly, we're going to do this again. The first thing that I need to do is I need to change one of the equations using its same y-intercept to be perpendicular. Since this one has a y-intercept that is not a fraction, I'm going to use this one. So perpendicular to this would be y equals 3x, and we're going to use the same y-intercept. So 3x plus 2. And just for future reference, because we're going to go back to using this one for our distance, the y-intercept here is 0, 2. So now I'm going to solve using this equation, the perpendicular equation, and the other equation. So y equals 3x plus 2 equals, y equals 3x plus 2, and y equals negative 1/3 x plus 14 over 3. So y equals 3x plus 2, and y equals negative 1/3 x plus 14 over 3. We're going to solve using elimination. Subtract, we get 3 and 1/3 x minus 8 over 3. Solve for x. 8 over 3 equals 10 over 3x. Multiply by the reciprocal, that ends up giving me 8 over 10, or if we simplify that, 4 over 5. So that's our x coordinate. Plug that into either one. Let's plug it into the top one. So y equals 3 times 4/5 plus 2, or y equals 12/5 plus 2 for 1. Make a common denominator. So here's our point. X equals 4/5, y equals 22/5. And then our other point, remember if we go back to our y-intercept in the beginning, that's 0, 2. So we're going to use these 2 points in our distance formula. So that becomes x's subtracted, squared, and then add that to the y's, subtracted, squared. So that's going to give me 4/5 squared plus 12 over 5 squared. And again, we can make these decimals just for a little bit easier. So 4 divided by 5 gives me 0.8. 0.8 squared is going to be 0.64. I'm going to add that to 12/5 squared, which is 2.4, times 2.4, which is 5.76. If I put those together, I get 6.4. So I'm going to take the square root of 6.4. And that should be my answer. Okay, so after doing several looks over my work, I regret to inform you that way in the beginning, this was a negative 14. So I need to go back and change everything to negative 14. But the remainder of this will remain the same, all the steps. It's just this is now going to be minus 14 over 3. So that's going to change everything. So just to recap, you would obviously need to make them both into slope-intercept form, and then you would make one equation into a perpendicular equation to that using its same y-intercept, and that y-intercept is going to be part of your end distance. And then once you solve with the perpendicular equation and the other equation to find your other point, then you still take the distance of those 2 points. So the process didn't change, it just helps to really pay attention to those negatives. Here's your lesson on that. All right, that concludes lesson 3-6.